All right, welcome back. Today we are talking about Charles's law. There he is, Jacques Charles. So he studied gases a little bit later after Boyle, and he was focusing on temperature and volume. And pressure is constant, so he didn't really care about pressure. So he says, as the temperature of an enclosed gas increases at constant pressure, the volume should increase. So temperature goes up, volume will go up. Here's the thing. Temperature always has to be in Kelvin. We are not going to be using Celsius because Kelvin is an absolute scale, so you won't have any zeros. And as soon as you see the formula, you're going to understand why. So we're going to have the formula V1, our original volume, over our original temperature equals our new volume over our new temperature. And the reason why we can't have zeros is because we can't have any zeros in the denominator of a fraction. So if we go back to reference table T, you will find that we have Charles's law here. Okay, so this is Charles's law. So the orange part. So notice that we don't have pressure. That's because it's constant. So if you wanted to use the whole entire combined gas law, you just put the same number in for P1 and P2. Or you just don't include it, and that is Charles's law itself. So volume over temperature. And they are going to increase at the same. It's a direct relationship. So as one goes up, the other goes up. As one goes down, the other goes down. Okay? So here we have some questions. A balloon contains 5.5 liters of gas at 24 Celsius. What would be the volume of the balloon if the new temperature was 58 Celsius? So first of all, we may not use Celsius. So I'm going to add 273 to both of those. So this is called 297K. And 58 plus 273 is 331K. So, volume 1, 5.5 liters. Temperature 1, 297 Kelvin. Volume 2, it's what I don't know. And temperature 2, 331 Kelvin. So if you look, my temperature has gone up, so I am expecting my volume to also go up. So 5.5 times 331 gives me 1820.5 equals 297 times V2. Let's divide both sides by 297, and I get 6.1296. So if I was a nasty chemistry teacher, I would say, please round to sig figs, which would be 2. So 2 sig figs would be 6.1, and this is temperature. No, sorry. This is volume, so it would be liters, 6.1 liters. Now, if you didn't have a mean chemistry teacher like me, you could probably keep 6.12, 6.1, well, actually 6.13, because that would 9 would round up, something like that. Okay? Pretty straightforward formula, and you notice that the volume did increase from 5.5 liters to 6.1. A gas occupies 11.4 liters at standard temperature. What temperature is needed for the gas to occupy 7.55 liters? So we start with our original volume, which is 11.4, and I need standard temperature. Oh, shoot, I don't remember what it is. Should probably go to my reference table. Their standard temperature, it's 273 Kelvin. I'll make sure you can read that. 273 Kelvin. 273. And I've gone down to 7.55, so I don't know my new temperature. So notice that my volume has gone down, so we're looking for our temperature to also go down. So let's make sure that it does, because if it doesn't, something happened. So 11.4 times T2 equals 273 times 7.55. 2061.15. So let's divide both sides by 11.4. And you get 180.80. So 3 sig figs, 3 sig figs, 3 sig figs would be 181 Kelvin. Okay? Which did go down from 273. Okay, that's Charles's law. Thanks for watching.